So now we were talking about redeem collateral, right? Okay, cool. So now we actually have a function, a valid function to deposit collateral. Now let's actually have a valid function to redeem collateral. So we're going to do the same thing. Function redeem collateral. We're going to do the same thing. It's going to take a uint256 collateral seed for which collateral to redeem. uint256 amount collateral. So we have public, and we're going to do something very similar here. We're going to say we're only going to choose a valid collateral by saying ERC20 mock collateral equals underscore get collateral from seed, collateral seed. And now we should only allow people to redeem the maximum amount they have in the system, right? So we're going to say uint256 max collateral to redeem equals DSC engine dot get collateral balance of user. Do we have this function? DSC engine. So this is one that I added in. It's going to get the collateral balance of a user if you pass in the user and the token. So if you want to pause and add this in, feel free to do so. Get collateral balance of user, where we add the address of the collateral and the message.sender. So it's going to get the total balance of a user. Oh, and this should be DSCE. And then we're going to bound the amount collateral to this max amount that they have. To make these always valid, they should only be redeeming as much as they put in the system. Amount collateral equals bound amount collateral. We're going to say redeem between 1 and the max collateral to redeem, because we don't want them to redeem 0, of course. And then we're going to say, oh, this is going to be public. Then we're going to say DSCE dot redeem collateral, address collateral, and amount collateral, right? So now we have two functions to randomly call. So we're going to be depositing collateral and redeeming collateral. Let's run this invariant. It only has two functions it could call. We go to the foundry.toml, fail and revert is true. Oh, and it looks like we found an edge case. So now we can read this and see what it's doing. So it's depositing some collateral, 1381 and 82, and then it's redeeming the collateral. I'm actually sure what's going on. So let's add this -VVVV to see more into the actual transaction that's failing. Oh, my goodness. We got an even bigger one here. So what are we saying? Oh, max is less than the min. Oh, looks like I'm messing up with my bounding. So it's not even really an issue. So if we go back to the handler, bound amount collateral, 1 max collateral to redeem. Ah, okay. So if max collateral to redeem is 0, this will break. So we actually do need to keep 0 in here. And then we can just say if, amount collateral equals 0. We could say if it's 0, return. Or what we could do is we could use this keyword called assume, like vm.assume, which will say, if the Boolean expression value is to false, the fuzzler will discard the current fuzz inputs and start a new fuzz run. So we're going to do if the amount collateral is 0, just return. Don't call this function, right? Because this is going to fail. So let's go ahead and run this again now. Compiler run successful. Well, would you look at that? We are now passing again. So people can, if we go back to the handler, people can now redeem collateral, and all of these redeemings are going to be valid, and all of these deposits are going to be valid, right? They can only redeem valid redemption amounts. Now, here's where this fail and revert equals true can be a little bit deceptive. Let's say right now, we're only letting you redeem the max collateral to redeem. Let's say there was a bug where a user can redeem more than they have. This fuzz test wouldn't catch this. It's because we have this fail and revert is true. If this fail and revert was false and we didn't have this line, right? And we just said this is the max deposit size. This is a test where we might actually catch that bug, right? And if we run this now, and with fail and revert is false, we are going to get a whole bunch of reverts. We are going to get bad transactions. However, And you can see, we can see the number of verts over here, and it actually is way less than it was before, which is awesome. And if we run it again, still way less than 8,000, which is what it was before. But if we have fail and revert false, we can actually catch this. So the Foundry team is actually working on allowing some tests to be fail and revert and some tests to be not fail and revert. So you can kind of pick which one for which functions instead of kind of having to blanket everything. So just keep in mind the dangers here, okay, of always defaulting to fail and revert equals true, okay? They have their trade-offs. And if you do fail and revert equals false, you can sometimes write these handlers a lot quicker.